kid story. It's a Kubernetes story. Phippy goes to the zoo. I'm bored, Aunt Phippy. Z slouched further down on the couch. What are we going to do today? Why not go see the animals, said Phippy with a smile. We'll go to the zoo. Yay! Z let out a whoop and ran to find some shoes. Yes?
Go.
Okay, just making sure. The first animals they came upon were the size of squirrels, furry and blue. Each little animal carried a tiny box as they increasingly zipped back and forth. Those, said Phippy, are pods. All day and all night they run back and forth carrying their little containers. Is that all they do, Aunt Phippy? Yes, see. For their entire lives, that's all the pods do. They run.
So, I know this seems a little corny, but it actually works. And what we are going to have is we have our Docker containers. And our Docker containers are going to be placed into a pod. And a pod is just a way to control or bring together a set of containers that are the same. We'll see later on where we get into how we scale those. But right now you can think of a pod as a collection of containers. And we'll actually see later on, I'll bring up our Kubernetes cluster and you'll see what a pod will look like. You'll have a base name of your container, and then it'll be a randomly generated like string that's tacked on to make them unique. So each container that's running, like when you do a Docker exec or a Docker run, you get your SHA of the running container. In the pod, you can actually, even though you have a pod of running containers, you can still navigate through the command line if you have the right access to a specific container and log into the container basically from that aspect. The handy things, we get environment variables that we can set up at the pod level. So that's where we're going to have things at the higher level. Also, it's going to handle volume mounts. When a container wants access to a volume, it's going to actually happen at the pod level instead of at the container level. If you go into the container, the pod's going to do all the work for you to get it mounted, but when you're at the container level, you get the mounts of the external volume into your container at that point. And you'll see that pods later on will really get into scaling and high availability scenarios. So one of the things, this is a little confusing here, because if you exit all the, if you terminate a pod, you're going to terminate all the containers in the pod. If you terminate a container that's running in the pod's actually going to go off and start another one for you based on your rules. So that's where the high availability is going to come into play. And we'll talk more about that later when we get into, there's something called ReplicaSets. Any questions on that? Pretty simple concept, just a group of containers that are running together.
Pardon, a quick question.
Yes.
Does a pod correspond to a VM when we talk about the physical architecture?
No, a pod is, so the question is, does a pod correspond to a VM? And no, it doesn't. The cluster is going to correspond to the VM. So the VM is going to sit on top of a set, the cluster is going to sit on top of a set of VMs. And we'll see down here, there's another a control plane that comes into play that allows us to manage how many VMs we're going to actually consume. So the scaling for Kubernetes works at two levels. One is at the cluster level. So if the cluster runs out of resources, it'll actually start spinning up additional VMs to add into the cluster. And then also at this level, at the pod level, when the pod gets overloaded, it'll start creating more replicas in the replica set to scale the number of containers. So we'll get to it. There's another layer in between that corresponds to where the VMs reside.
Thank you.
Yep.
As Phippy and Z walked on, they saw a large glass enclosure. Pressed against the window was a line of happy little meerkat faces. Those are ReplicaSets, said Phippy. As Z watched, the face on the right grinned widely and tipped itself off the ledge. In unison, the others hopped over to fill the space. And then an identical meerkat scurried up on the left side. Every time one little replica falls, another one hops right up, explained Phippy.
Yeah, so this is where we're going to, the replica sets are going to be managing the pods. They're going to be looking at the pod and seeing what's running in it. And you can set up rules around the replica set, saying that I want it to start with the default of 5 instances of this container running in the pod, or I want it to start with 1, for example. And then you could decide, you put rules around it to say how quickly I want it to scale, network traffic, CPU load, those type of things will cause it to start scaling. So if something, this is where it gets into the whole pets versus cattle analogy. In the Kubernetes world, the containers running in the pod, if they die off, we're just going to get a new one within a couple milliseconds. It really depends on how big your container is and what you have going on as far as startup speed, but it's going to happen very quickly. And what will happen is the replica sets are also going to control all the networking for you. So if one of these dies off, one of these containers in your pod dies off, a new one will come in and the networking will get all reestablished for you. You don't have to worry about any of that. You just start communicating with the pod at that point. Any questions on replica sets? It's one of those things you just set up and you forget about. When you define it, you just say, and they're so tightly tied with a pod that it's hard to pull them apart. Like when you go into like a Kubernetes dashboard, you hardly ever look at the replica sets itself. You're looking at the pod and how the pod's responding.
Walking further, Z pointed out a clump of burrows and warrens. While there were plenty of signs that the area was inhabited, neither Phippy nor Z could see a single movement. The secrets are in here, said Phippy, but you can't see them without these decoder glasses. Z took the pair of glasses Phippy offered, slid them on, and blushed. Oh my, I think I'm ready to go on now, Aunt Phippy. Z handed back the glasses, and onward they went.
So this is a little weird in the story. They just kind of like stuck this in there somewhere. They're like, oh, we got to cover secrets, so we'll put it right here. Basically, there's commands that you run at the command line that allow you to encrypt, not really encrypt, but encode your user ID password, and then from there you upload it to your cluster. So it can be plain text type of user ID password. It could be files. It could be environment variables. And what ends up happening is when you attach your secrets, let's say we're going to do like a database connection string is going to be what we want the secret to be. We're going to give it a name. We'll call it DB connection. We're going to go ahead and encode our connection string, and then we're going to upload it to the cluster. Now on the cluster side, I get to reference that just by an environment variable. It'll be $DB connection is how we can reference it. So if we wanted to use it in our program, like in our Tomcat startup, we're just going to be able to access that from the environment variables. Pretty much everything that the way that Kubernetes exposes things is mainly through environment variables. If you want to find out what other pods are out there, they'll be in the environment. And there's like a naming convention that's followed. So if you need to go find another pod that you want to talk to, you can look at these well-known environment variables, and that will abstract out like the IP address, for example, for you. Secrets, like a file-based secret is going to be your SSL certs. Those will be placed into a secret and added into there. And what that does is allows us to abstract out or pull apart the configuration data from being placed inside the container. Because one of the things when you do your Docker build is you don't want to go and add your secret when you do your Docker build into your container, because that means that anybody that has that container can go in and grab your secret, your public-private keys, and just by grabbing the image, we're not even running anything. But if we do it at runtime through the secrets, they're injected and people can't get to them at that point. So that's one of the things that they introduced. It's a weird place in the story to throw in secrets, but it's an important part when we look at SSL keys, SSH keys, database connection strings, those type of things.
I have a question.
Yes.
Do the secrets change for, let's say you have people who's hitting a test database? Do you have to modify the secrets for deployment?
What you would do is, yes, you'd have a set of secrets for testing, a set of secrets for production. Both those would be in the cluster. And then you would, depending if you're running a single cluster for both test and production, let's say, so you have a single cluster. When you go to start up your container, you're going to have to pass in and tell it that I'm starting up for test, and I need to go grab the test secret as an environment variable. So if you're running two separate clusters, if you're running a dev cluster, a QA cluster, and a production cluster, those are all separate clusters that you're going to upload. You have to upload the secret 3 times to those different clusters. And then from there, you can reference the same environment variable on startup of the container. So it just depends on how you have your clusters set up. Try to minimize the number of clusters. You don't want to, because they'll scale for you, you don't need to scale them on their behalf. Let it scale for you. Yep.
A group of iguanas gathered near a large slingshot along the shore of a pond. An island stood in the center of the water. An iguana threw herself into the slingshot, and the other iguanas launched the little beast towards the island. The deployments release a group onto the island. Right now, they're trying to get 3 out there, said Phippy. At that moment, another iguana rocketed into the air but missed the island with a colossal splash into the pond. Phippy said, if they miss, they just keep trying until they get as many as they need.
Yeah. So one of the things when we go and take our container, we're going to have to do a deployment. And basically what that does is the deployment step tells Kubernetes to go download this container into the pod that has been defined into. So when we do a deployment, we're going to pass in certain things. This is the name of the pod. This is the name of the replica set, the cluster that we're going to. And with that information, and we do the deployment, it's going to go out and start downloading stuff. And it'll look at what the replica set's been defined as, saying we need 5 of these containers in this pod. And it'll start downloading and starting up these instances for you. So it makes it very simple to get a nice state in your cluster through the deployments. You basically do it once, and then Kubernetes is going to do all the hard work for you. Like I said, if one fails, it'll start going and trying again. One of the common things that you run in with deployments is you've typed in the wrong image name. So you get this weird error that says image back off. And what's happening when you get into the logs is it's trying to download an image from like Docker Hub, and it's not found. And it'll sit there and keep on trying and trying. And then what it'll do is actually do a progressive delay. So initially it'll try really fast, and it'll start slowing down, waiting for that to happen. What you'll recognize is, oh, I had a typo, or I grabbed the wrong image out there. You make your correction and redeploy, and it'll go out and fix it and start downloading the correct one. Image backoff is one of those weird ones that you'll see, but that's typically the case, is you've got a typo somewhere. And it's going to try, like I said, it's going to take the information about the replica set and start scaling the pods based on that. You can deploy just a single pod, or you can deploy 50 pods as you want in that process. What will happen is each one will be listed as part of the output you get when you look at the deployment log. There's a kubectl command that says get deployments, and it'll list all the deployments that have occurred.
Quick question.
Yep.
So if you have an app that like runs Node.js and has a bunch of AWS infrastructure and so forth, that they fit into this kind of deployment as well? Or?
So if you're running Node.js as a,
Make sure that they,
so the question was, if I have an app that's running Node.js and it also has some AWS infrastructure pieces, how the deployment's going to work. So in the case of Node.js, that would be placed into a container, something like the AWS database, if we're going to use like the SaaS MySQL from AWS. That's going to live outside of Kubernetes, so that would have to be provisioned as like a prerequisite before your Node.js deployment goes. So things that are, if you have like a standalone application that's running in a VM, like you're in this hybrid world where you have Monolithic running in a VM, and you've got some Kubernetes. That's going to be outside of the deployment world for Kubernetes. So you're going to have to go ahead and provision that through another method, and then go ahead and provision the Kubernetes piece. That makes sense? Mm-hmm. So things like databases are usually going to be, most people don't run databases as containers. You can. It gets a little tricky with the persistent storage, depending on the database. Because the reason is you have multiple processes trying to access the same file system, and they just crash and corrupt the database. So. All right.
Several stone pillars arose from a grassy knoll, and at the top of each sat a vulture. As Z and Phippy watched, one vulture spread its wings and flapped off into the distance. No sooner had one left than another took its place. Z asked, "What are they doing?" "Those are daemon sets," said Phippy. "They make sure to occupy every pillar, rain or shine, day or night." "I bet if we added a new pillar, a new bird would land on it faster than you could say kubectl," chuckled Phippy.
So this is where I was talking earlier with the question we had earlier about the VM that's supporting the cluster. So they didn't really go into it, but it's called a node. So you have the VM, then you have nodes, and then the cluster sits on top of the nodes. And what will happen is, or reverse, in the cluster are nodes, and those nodes are supported by underlying VMs. And what will happen is, this is the first level of scaling that we'll get into, where if we're running out of resources at the VM level, that the cluster is going to go off and say, I need more nodes, which are going to be more of the pillars. And when we do that, we'll get the pods being deployed out onto those for us automatically. So that's one of the levels of the scaling that the daemon sets will do. So these guys are watching what's happening at the node level. They're out there, you never work with them. It's one of those things when if you're going to start scaling to, 100 different pods that you're running in a cluster, you'll start worrying about daemon sets. But to start with, the default it works fine. So one of these, you have to know that it's out there, but most of the time you just ignore it when you get started with Kubernetes.
As they walked on, they saw an aquarium with an enormous reef. Edge to edge, it appeared that the rock would keep anything from passing from one side to the other. Z watched as hundreds of tiny fish made a dash for the center of the face of the rock. At full speed, the fish swam into a hole, bored into the rock face, and momentarily vanished from sight. Z let out a gasp. Multicolored flashes erupted from the opposite side of the coral. Instead of coming out in a single hole, the fish seemed to materialize from tiny fissures all over the far side of the rock. Ingresses are beautiful, said a dreamy-eyed Phippy. Enchanted, Z muttered, uh-huh.
So this is where we, this is where it can get a little confusing because, especially in the cloud environment, because when you get into like AWS or Google or Azure, you're going to have a load balancer that's going to be, you know, you have, what is it, AWS is Route 66 is the load balancer. So those are different than the load balancers that we have at the Kubernetes level. You'll typically have the ingress for the cluster, and then if you wanted to have multiple clusters, this is what like Uber does. Uber has 10 data centers over the US, and they run multiple clusters at every single data center. And then they have the load balancers at the AWS layer or Google Compute. They're under Google Compute. They'll have the load balancer at the higher level, taking traffic coming in and routing it to the right data center based on your location of where you're currently using. So that's the first level load balancers. That's outside of the Kubernetes world. Now, when we come into the cluster, we have to tell it how we're going to get into the cluster, and that's going to be our ingress. That is going to be, you'll see when you define your container, or your pod, I'm sorry, you'll have to create a load balancer pod. Now, you can take the default load balancer that Kubernetes provides, or you can put like an Nginx in place as the load balancer. So what we did for our SaaS version was we used Nginx as our load balancer container, and that's going to be in a pod, and it has a replica set. So if we need to scale that, that can happen at that level as well. But Kubernetes has a built-in load balancer object you can think of as well that you can configure. Really depends on what you're going to do when you get a transaction coming in. Where does it need to go to? Like I said, through the environment variables that are exposed between all the different pods, we can actually create pretty decent rules in Nginx saying, I get this URL, I needed to go over to this pod for that request to be satisfied. So that's going to happen through the load balancer. There's another thing, I don't think we get into this, but it's called service mesh. A service mesh is even a fancier load balancer. What it does is allows you to look at any of the data coming into the HTTP transaction. So if you want to look at the user that's been authenticated, if you want to look at you know, what browser that they're coming from, you know, those type of things, any of the header stuff or the data you can look at with service mesh, and then you can do routing based on that to the different pods. So that's one of the things. You definitely need ingress. If you don't create one, your cluster won't work. You'll never be able to get get a transaction into it. So you have to create an ingress of some sort.
Z pointed to the raccoon sprawled motionless in the next enclosure. What's wrong with them? Suddenly one sprung to its feet, did jumping jacks, then settled back down for another nap. Those are cron jobs, said Phippy. Mostly they just sleep, but periodically they spring into action to do a specific job. As she spoke, another bolted upright, grabbed a broom, swept the entire enclosure, and then dropped off to sleep again. Aunt Phippy, can I bring one home to clean my room? Phippy laughed as they walked on.
Yeah, so I've actually never had the need in our application to use cron jobs, but they're just going to be a pod that spins up does the transaction, and dies. This is going to be configured when you configure your pods. You'll configure your cron job. There's all of Kubernetes, they're called resource definitions. So a cron job, a daemon set, a replica set are just different types of resource definitions. So you'll create a resource definition for your cron job to go off and have it run. Basically, it's going to run the container at such and such point in time and do its work, and then basically die off.
Die off or nap?
I have a question about
Nap.
that. Is Tecton replacing cron jobs?
No, Tecton. So Tecton, the question is Tecton replacing cron jobs? So Tecton is a Google project that's part of the CDF that focuses around pipelines. And what they're doing is right here, they're extending Kubernetes through custom resource definitions. These are written basically in Go, and you get to extend out and do your own definitions to go ahead and perform some sort of task inside of the Kubernetes cluster. So one of the things that Tecton does is they have a task type, and it says this task is going to do a git checkout. And what they do is they have a pipeline resource definition, and that pipeline resource definition says how to go from point A to point B to point C. And when I go at point A, I'm going to run the task git checkout. The step number 2 is going to be do a Docker build. Step number 3 is going to be do a deployment. So the whole Tecton project is exploiting the Kubernetes architecture around the CRDs to be able to make Kubernetes do more. It came out of the Knative project. Knative is basically the underlying plumbing for Kubernetes. Did you read that one yet?
No.
I explained it and you haven't read it.
Z halted abruptly. In the distance, a black railed fence arose. The arches above the pen were marked CRD. Between the bars, Z could make out some peculiar critters. A giraffe with a hippopotamus head, a snake with raccoon ears, a lion with a beaver's tail, a unicorn with no horn. Z wasn't sure that she liked the look of that place. Oh, said Phippy, a look of concern on her face. Oh, look, it's lunchtime. We'd better head home. With a mild look of relief, Z complied. Can we stop at Captain Cube's shake shop on the way out?
So, like I said, the CRDs allow you to extend Kubernetes, place tasks in there. More than likely, you're not going to be going at this level and redefining how Kubernetes runs, but it's just good to know that it's out there. You'll see some CRDs come in around volumes. One of the things that you'll run into is persistent volumes. You know, how do you get external data into the cluster at the file system level? So you'll see different CRDs for the different, if it's going to be an NFS mount, if it's going to be a Windows share, if it's going to be, you know, like a Git repo, some sort of that, some type of that. Those are going to be CRDs that are going to allow you to mount volumes differently. That's where you'll see them mostly, unless you get into Tecton at that level. So we're done with our good story. Thank you, Celine. One of the things that you can do is you can label everything. So you can label your containers, you can label your pods, you can label your replica sets. And what this allows us to do is to really query what's happening. So I want to find out what's running in this namespace for this stage of the life cycle. So you can do you can put a label on there. You can put a version label on on a container or a pod. And what this allows us to do is we can actually create 2 different containers from the same, let's say in your Node.js example, we have version 1 of our application and version 2. We can actually deploy version 1 and version 2 into the same cluster at the same time. We just label them differently. So this is V1, this is V2, and they're actually going to both run at the same time in your cluster. Now that's great, but how do we get to when a transaction comes in, we get to the right one, and that's where the load balancer can look at the labels and say, this transaction is coming in, this is for the beta version, route this over to the beta containers that have the beta label attached to that pod. So it allows you to do this advanced routing and have multiple things running at the same time in the same cluster. And you'll see things where people use, like it'll say blue-green. They'll throw a label out there for blue-green, and they'll say this label is 20% for green, 80% for blue, and then they'll go ahead and change they'll go and query and saying, okay, we're going to change the label. We're going to go grab the green one, and we're going to change the percentage now to 90%, and we'll go and change the other one back to 10%. So that querying allows you to do stuff at the command line for like blue-green deployments, canary deployments, those type of things. And that's all how the load balancing is happening inside of the cluster itself. Namespaces. This is, like it says, it's a grouping mechanism. And you can group together basically everything. If you're at a company that has multiple applications, what I've seen is typically every application gets its own namespace. It's its area to play in. So if you have the teller application and the loan application in the same cluster, you can put them in separate namespaces. And what that does is keeps everything, all the traffic and everything confined to that namespace. There's ways to go outside of the namespace, but typically it makes it easier for isolating everything for a particular application. So if you have a bunch of applications you want to share the same cluster, definitely use namespaces. Oh, and also you'll see, like, because Kubernetes is actually Docker containers itself that are running, you'll see that there's a system namespace, and Istio will get put in its own namespace, the server's mesh. So that will let you, you'll see that out there, but by default, you have to go like hunt those down. The default one works fine. So block storage. This is where we want to expose external data and persistent, because remember with a container, once the container dies and you kill it off, anything that was saved in the container is gone. So if we have a database, or if we are writing for our web app is taking PDFs and uploading them from a website, and we want to save them, we don't want to save those PDFs in the container themselves. We want to save them on a persistent volume. And they'll get mounted over just like a regular Linux mount as part of that process. And this is where I was talking about the CDF, CRDs, based on what type of persistent volume we're going to do. S3 is slightly different than Google storage. So there'll be a different, basically, resource definition to allow you to mount that type of volume to your containers and your pods. What ends up happening is they look and act just like regular file systems, which is great. There are some weird, like in Google's implementation of volumes, because of the way they have their data centers structured, you can't have, you can only have one container in the pod having write access to the volumes. Okay, think about that. So here you are, you're trying to scale out, and you want to have 100 containers running in your pods, and you're doing all these PDF uploads, but only one of them is allowed the right to it. The other ones are going to get errors, and that's because of the way the underlying block storage is designed. So what you have to do is you have to change it over to a more of like an NFS style storage that allows for multiple writes at the same time from any container. So just be aware of that depending on what you're trying to do. Databases, like I said, databases, you want to, like if you have Oracle running or SQL Server, those are going to be addressed through an IP address. So those you typically don't have to worry about. Unless you're trying to run like a MongoDB, something like that, those get a little trickier with the way the persistent volumes need to be mounted and shared. No problem. So services, this is where the IP address gets assigned to the pod. So you have a pod, it has a set of containers. You want to make sure you create a service for that pod, and that's going to give you link an IP address with that pod. So that gives you that access. So, and then it'll expose the name of that service and the everything as environment variables. So you'll be able to, and also it does some stuff internally to the host table. It'll dynamically write the host table for that container and keep it updated. But the service, when you do your deployment, you deploy your containers or your pods as well as your service. You can redeploy any of this stuff over and over. It's not going to hurt anything. Kubernetes recognizes if it's already out there, it's not going to do anything with it. You guys ready to get into microservices? All right. So microservices is a way to take an application and its transactions, and instead of it all being tightly bound together at compile time, where we go figure out compile errors, link errors, those type of things, we're moving that to runtime. And some of the things that we do at the runtime level is we're going to make our transactions or microservices smaller. When we talk about microservices, you usually have one microservice per container, typically. Or you may have a small set. You want to keep it to a functional level. And what this allows us to do at the microservice level is really break apart our application so we can test just that one part. If we're going to go and get the user profile, that we're going to have a transaction that's going to come across and say, give me the user profile. And then it goes to a few hundred lines of code that goes and retrieves the user profile from the database, returns that back to the requester. We know that that few hundred lines of code can be tested, and we can harden it, and then we can forget about it. So things, if you think about a user profile, if we're going to go and grab a user profile, what are the three main test cases that we have that are going to happen if we go to get a user profile? Anybody?
Read from the database, update the database.
No, we're doing a read.
Okay, read from the database.
Yeah. So what happens when we're going to read the user profile from the database?
Make sure the query is correct.
So we have a failure, right? Where we got something messed up with our query. It's either it's gonna fail altogether. We're gonna have a database error. We're gonna get a success. We're gonna get the data that we asked for. I want my user profile. It went off and returned my user profile, not your user profile. So we get a successful return. Then we get another one which is not found, right? So those are our three test cases that we have for that microservice. Database failure, successful read, not found. Think we can make some test cases around that pretty easy? Do you think we can, after we test that for a little bit, do we forget about it? Yeah. It's going to go on the back burner. I don't want to say forget about it, but we're going to put it on the back burner as part of that process. Now, where it gets a little trickier is if we're going to go get my user profile and I have to go off to LDAP, and that's another service. So to get my user profile, I have to go off to LDAP and return some information from LDAP, and I have to go to return some information from accounting. And then that's going to get returned back to, that request is going to get returned back to. now we have to worry about the version of the microservice that we're going to call to go get my accounting information. I have to worry about which version of the service I'm going to call to go get my, wherever it was. Yeah. So when we have a service calling another service, we're going to have to start thinking about which versions of which microservices that we're going to be utilizing. And that's where the configuration management of it. Normally we'd do that to compile time. We just compile it all together and say, I want this version of this jar file, I want this version of this jar file, or library. We're going to bring it all together, but we're delaying that to runtime now. So this is a company, this is from SC Times, and they broke down their whole application into microservices. I can't remember how long it took them, but so they would go through and they would have these dependencies, and what happened is that we would release an update to a library, and then one service would use the new service, and now all of a sudden all these other services were using an older version, and we had to try to keep track of which service was using what in which version of the library. So as we break this down, you'll start out with a spreadsheet, guarantee you. First you start out with it in your head, then you start out with a spreadsheet, and then you'll go, I can't deal with this, and then you go back to where you used to be and did it at the compile time, where you had tools there. This is what our DeployHub focuses on, is this problem. This is like what's called the Netflix Death Star of their microservices. This is a small portion. It's like 10,000 microservices that are connected together that make Netflix run. So you can see there's a lot of relationships that are happening. But like I said, one of the good things is we can write them, we can test them, and then we can put them on the back burner. So when we're going to go from our monolithic world, we have all the tools. We have the build tools, NPM. We have Maven, Gradle, OpenMakeMeister. You got tools like Artifactory, Nexus. Those coming into play, all to figure out how to put something together, and that all happens at compile time. Now, microservices is all being shifted over to runtime. The amount of lines of code that we're dealing with is going to be much, much smaller, but we have many more of these containers and repositories that we're going to have to keep track of. So it's nice because we are going to be doing less branching and merging, but at the same time, we're going to have hundreds, if not thousands, of repos that we're going to be looking at. So a plug from us, the sponsor. We deal with all the microservices. There is a SaaS version out there you guys can use for free. That'll help get you started with Kubernetes deployments. And also it's based on our open source project called Ortelius. Ortelius is the first guy to make, was it Abraham Ortelius? He's the first guy to make an atlas for the world. So as we go through and start breaking apart, and one of the things you can do when you work with your microservices and start thinking about it, you don't have to do them all at once. You can take your monolithic application and let's say you want to just take single sign-on. Just tackle single sign-on, make that a service. If you want to do, like I said, user profile, do something that's small and start there that's kind of contained in its own box that doesn't have a lot of dependencies. You want to go down to the lowest level of your dependency tree and start there and make that a service. Instead of trying to start like in the middle and you got these weird dependency trees and stuff, you want to start at the lowest level, make that a service, and let your monolithic application start consuming through your transactions that microservice. as part of that process. But when you start doing this, what you want to do is there's a, what's the name of the website?
Microservices.io.
Microservices.io. He talks about domain-driven design. And domain-driven design is how you're going to organize basically your code into functional groups and hierarchies. So I don't know if I have it in this one, we'll see. But if you have like a web store, if you want payment processing to be used by multiple teams at your organization, that's going to be part of your domain, payment processing. You want to make that a higher level in the domain structure so it can be inherited by other teams. It kind of goes along the lines of object-oriented programming, but object-oriented programming I think gets a little too detailed, too low level. And you want to think about functional blocks that you can put in a domain hierarchy of the lower pieces are going to be able to inherit the upper pieces. The other thing you were going to need to talk about and need to make sure is tracking which version of the container and how that relates to which version of your source code. And from there, how that is related to what's running in the cluster. You know, because in the clusters we can run multiple versions of the same container at the same time. And we have to know who's the consumers of those. And then also we got to be able to make sure we deploy it as part of the process and keep track of what's been deployed. So again, another plug for us. This is just a graphical view of a web store. It's kind of hard to read here, but basically these are the different microservices. You got ad service, there's a front end, the catalog, there's a load balancer down here, recommendation service, payment processing, shopping cart. You can see how when you start talking about the different pieces of how an application is put together, and then we're not even getting into like the different classes, you know, the different objects that are part of a shopping cart. You know, we're not down that low. We're just at the high level functional views and breaking those into the services. I had a question yesterday on a webinar I did, and somebody was asking, like, how do you figure out how many microservices you're going to have? And you can basically relate it to how many tables you have. And if you have, you know, like in DeployHub, we have, I think, 125 tables. So we basically have 125 microservices. And so you have a create, read, update, and delete for every single table, basically. And those are grouped together into a single microservice. Now, down the road, if you need to do scaling, we can break out like the retrieve part. So we can have the retrieve in its own container, and then all the other non-used stuff off in its own container. And what that allows us to do is because the read transactions are typically the ones that need to scale the most, that allows us to scale that separately from the update pieces. Okay, any questions? Making you think.
Yeah, definitely.
Here, let me pull up another PowerPoint real quick, and I'll show you the domain-driven design here a little bit. You know.
Sure you're sharing that, because I don't know if you were sharing your screen or not.
Yeah. Thinking about it. Okay.
Did you stop sharing, reshare that?
No, it's still in our PowerPoint. So can you guys see? Should be able to see a new slide I put out there with a bunch of triangles on it. They all fell asleep out there.
No, we got you. We're here.
All right, cool. So we're going to get into a little bit of the domain-driven design and a way to think of that from the microservices perspective. So as you can see here on the website A, this is kind of like our monolithic, not necessarily monolithic, but yeah, we could go that route. We'll go monolithic. All this is kind of like smashed together into a single WAR file. So we've taken all these pieces, shoved them together into a WAR file, and that's how we're running our application. Now, when we start breaking out into microservices, each layer is going to be its own service or category of services. And what that allows us to do is when we get up to, on the right-hand side, website A and website B, we can actually, this can be two different teams that are writing their own websites, and they're going to consume the bottom part. They're going to consume the cart, the checkout, the sign-in, the credit card processing. All that's going to be reused between the two different teams, or this could be two different versions. 4th of July, Labor Day. So these are the changes for the front end for 4th of July versus Labor Day, but we're consuming everything else in the back. Now with putting all this into the Kubernetes cluster, we could run both website A and website B at the same time in the same cluster and just use a service mesh to route people to the right version. So we have developers coming in for 4th of July. They want to hit that. We route them through the service mesh to the 4th of July version. The Labor Day version, we can do that, route that way. And you can set up defaults that way as well. What this allows us to really do is to, we're basically going to start testing in production. Especially with like read transactions. Update transactions gets a little trickier. You got to do some mirroring of data to do an update, or use like test accounts and stuff like that in production for the update transactions. But basically, when we're looking at our website and pulling that information down, we're going to be having testing in production and development in production. That's the direction that we're headed. I know the state's going like, oh my God. Really? We're going to be running development and everybody does it today. They just don't tell anybody.
So this is more of a, how that routing's done is more of a service mesh discussion. And there's a company out of Denver called Aspen Mesh that's building on top of, I think, Istio. It might be Linkerd, I'm not sure.
Istio.
Istio, and we might, if this is an area of interest, we certainly might be able to get them to come down and present to us. I know they presented at some DevOps meetups in Denver, so it would be fun to have them come down and talk to us about that. It's a whole different ball game when you start adding service mesh and the idea of just having one cluster and getting routed based on persona, a developer persona, test persona, production persona. Because basically when you're ready to go to production, I don't know, that's why I was asking the secret. If you could easily switch a database then to a cluster based on a secret, because then you could just say, okay, I'm going to update my secret for this particular cluster and then reroute everybody to that. Because then you're not redeploying, you're rerouting.
Yeah, the thing with this is, I'm working with another part of the state that they do some weird stuff. I'm trying to wean them off of. But they go through and they compile for dev, and then they test, developers test, and then they decide it's good to go. They recompile for QA. They decide that the QA testing is good to go. Then they recompile for production. And then they throw it into production. So what that means is you're deploying something that's never been tested, right? Because you just recompiled.
Mm-hmm.
So you've really never done testing. That's why I say you're not doing testing in production anyways. We just don't tell people that's what we're doing. But what in the Docker world, we're creating immutable containers. And those containers are then being placed into the cluster and allow us to use the same container that's been tested the whole way through. So we're not introducing another compile. We're going to introduce, new database connection, new SSL cert. Those types of configuration data is going to come in from the outside. But what we're testing all the way through the whole pipeline has never changed. Big plus. The number of times that it's been hit from development all the way out to production is going to increase dramatically versus compiling and releasing into production and hoping you pull in some bad code. You pulled in the wrong branch at compile time by accident.
So why don't we take, at this point, let's do a bio break and let people get some pizza, and then were you going to bring up kubectl or anything?
Yeah, we're going to bring up.
So we just take like a 5-minute break and come back and bring up kubectl.
Okay.
And let the folks know.
So guys, we're going to take a 10-minute break here, and we'll come back at 1:45. And we're going to get into working with, I'll show you Kubernetes in running in Google, so you get an idea of what it looks like. Okay guys, we're going to get started back up here. Let me just share a different screen here for you. Share my whole desktop. Okay, so we're going to jump into what all this really looks like. And let me get some windows out of the way here.
Also, I think O'Reilly should write more children's illustrated.
CNCF too.
This one came out of the CNCF, and
They have an illustrated guide to Kubernetes as well, and then they have Phippy goes to the zoo.
but
You can download it, you can order them.
it's actually really helpful for understanding some of the basic concepts. The other one goes into a little more detail. Okay, so you guys should be able to see that my GKE environment. For getting started, I found that the Google Compute was a great place to start. I think that you can sign up and get $200 or $300 worth of credits when you sign up. So it gives you probably about 3 months worth of free time on their machine to do what you need to do. And you have different projects. You can see I have a couple different projects out here. We're going to be working with this one. So what we're hosting here is our SaaS version. So this is the website that is being hosted by the Google Compute. That's the login. There we go. So, and what we have, and this is where the labels come into play. We can see that I have a couple clusters out here. The ones that are saying no pod scheduled, that is because they're turned off. You can see I have no CPUs and no memory assigned to them. So in this case, I have a cluster size of 1, and I've told it to go ahead and use 2 CPU cores for my VMs. If we go into the cluster, and we can see all the details about what's happening at this level. Whether I want auto upgrades to happen. There was a security patch that came out that we're waiting for a time frame to put in place, because the way it does it, the way we're set up, it's going to go ahead and take down the cluster for a few minutes. No, it's still running. I'm just trying to get out of the way. So here's our node pool, and this is where somebody on was asking us about how the nodes, the VMs are structured. So let's see if we can see it. Can't remember where they hide it now. I think that's the guy. Okay. So at this level, what we're diving down into is the actual VMware details of what's happening at the low level. You never go here. It's one of those, you provision your cluster at the high level, and then from there, you just work with the cluster. So I don't even worry about the underlying nodes that are in my pool at this point for what we're running for our website. So within the cluster are going to be our workloads, and these are going to be the containers or pods that are out there and available. The ones that, this is where that labeling comes into play. We'll do cluster 2, and we'll filter this out. So this is basically, we've broken up, like we're going through the same dilemma with DeployHub, our SaaS version, where we need to break it up into smaller microservices. So our first step was basically break it up into front end, back end. That's all we did. The back end part is just all our RESTful APIs, and the front end is just handling the JavaScript, the website, those types of pieces. Nginx is our entry point, our ingress, and because we're running Postgres hosted, we actually had to put a Postgres load balancer in play here as part of that process. And you can see that we're currently just running at one pod. If we go into this one, into our general, what we have here are the containers that are running. So right now we can see that we just have, and this is where I was saying the container gets this weird extra number, and that's going to be, gives it the uniqueness. Even though we're going to have the same instance here coming from our Quay repository. So I'm actually going to go ahead and scale this. And watch it scale. I just have it. So it's saying that we don't have, this is the replica set setting, and it's going to go through and tell us that, look at this level here, it doesn't have minimum availability. So I told it I wanted 4 pods out there, 4 containers in the pod, and it's going to go through a process and start scaling that for us. And what we'll see is, we'll see the containers coming across. So they all are going to end up with a unique ID, and we'll go through this where it's going to scale and it's creating the containers for us. And then it's going to attach. Now we have all the containers running. Now one of the things, they're all going to be based on the same version here. So I literally just scaled this manually as part of that process. For just starting, like what I have as my default, I just have 1 running. So if that one dies, it gets replaced by another one. I'm not worried about heavy traffic where I have to scale. I have 20 of these things running or anything like that at this point. So we got our successful criteria here. And you can see down here, I have a couple of secrets that are attached at that level. So I have my database secret, and then one of our other secrets for our SSL secret attached to this pod.
Could you do this auto-scaling wise, have a policy in place?
Mm-hmm. Yeah. So you can go ahead and put the auto scaling in place and get fancy on that level. One of the things that it does do is if I were to put a new version out here, So for the same pod name, the DHMS general, if I were to release a new image out there, it'll recognize that a new revision is coming out, and it'll actually go through and take down and start redirecting traffic to take offline some of these containers and start placing in the new version in place. So you get this live rolling update automatically for you by default. So you can actually set it up so your website is never down, which is great. You know, you never have to, it'll just do this. Kubernetes, when you do the deployment and you say, I want a new version out there, it'll handle everything for you at this level. Yeah.
Over AWS Fargate, what are the benefits Kubernetes have than AWS Fargate?
What's going to happen? So the question is, how is Kubernetes going to have an advantage over AWS Fargate? Correct. I'm not 100% sure of the Fargate. I believe Fargate is handling that at a VMware layer.
No, it's sitting on top of ECS.
Okay. All right.
But auto-scale.
Yeah. So the Kubernetes auto scaling is going to scale a particular service. So like we have our user profile service. We can scale that independent of any other services. So if I want to scale my front end faster than my back end, I can do that with Kubernetes. Or on the AWS side, I think you're going to be tied to scaling more stuff all together at once. But I'm not 100% sure because I'm not that familiar with that product from that side. And then at the cluster level, like I said, there's an auto scaling at that cluster level as well to say this cluster is maxing out resources. Now go ahead and start adding more VMs to it. And that's another level of scaling that happens with Kubernetes. I believe the
Question from Albuquerque, please.
Yeah, we have a question.
Yeah, go ahead.
Yes, when you choose to auto-scale that container and have 4 different pods, does Kubernetes apply the liveness check and readiness check defined on the YAML file? And the YAML file, there is this property which is liveness probe and readiness probe. So
Yeah.
Does auto-scaling also carry out those tests before it goes live?
Yes. Yeah, it's going to go through whatever's been defined. So if your YAML file has been applied to the cluster for that pod, then the auto scale is going to look at those rules for how to achieve the end goal. But if you forgot to apply your YAML file to the cluster, then it's going to get ignored. Does that make sense?
Yes.
Yes, thank you.
Yeah. Because there's a way, if we look at, we'll pull this out. I don't know if you ever looked at a YAML file for Kubernetes. It's one of those like, I'll go this route. Let me try it. I'll go this way, I'll go faster, I think. I'll let that run in the background there. Yeah, so what's going to happen is whatever's been defined, it's a plus minus thing with the YAML files. They're easy to get started because you can provide just some basic information about your pods, your services, you know, what your cluster name is, and all that comes out nice and is pretty tidy. But if you ever have to go backwards and query the cluster to get it, create a YAML file, you get all this other default stuff that is just like overwhelming. I mean, it goes from a few hundred lines to 10,000 lines if you want to like reverse engineer it. So make sure you version your YAML files with your source code because it's going to be pretty intense when we look at it. Let's see if it, yeah, so like you were saying, let's see if I can get up. Let me run this again and get it to a file. See if I can make this visible for you guys. The color is awful on it, but let's see if we can make it work. So this is what's been applied, and this is what the auto scaling is going to look at. So as long as you've put those rules in place, we'll be able to go ahead and check that, and the auto scaling will follow those rules. So this is where you're going to have your, I believe what you're talking about is going to be at the replica set level. And this is where it talks about if the pod fails, how we're going to restart it, those type of things. There's also ways to, image pull policies is a good one. I always tell it to pull down the image no matter what, instead of just reusing the image that's there compared to the SHAs. It's just one of those things that I do to make sure that I have the latest version I want as part of that process. So keep track of your YAML files, or you'll be regretting it down the road. So that's where we scaled our pod here. Now on the services side, this is more like the networking side. Might go away. And this is where our network is coming in.
Quick question
Yep.
about what I just saw. Was that a CLI with the Kubernetes or a Google platform?
There's both.
Yeah.
So the way you talk to Kubernetes is through the kubectl command line. Now each provider, cloud provider, will, and even like Minikube, will give you a couple commands to run to connect, do some configuration data to connect your kubectl up with the cloud. There'll be things like what's your project name, what's your login, which region, those type of things. And once you fill that out, like through gcloud, you do a gcloud config, for example, you fill out those parameters, and then it'll generate the underlying Kubernetes config file for you. And then from there, you just do the kubectl commands, and it acts just like it was on your PC. So the services and ingress, you can see that these are all the services I have out there. These are all internal IP addresses, all the 10 dot somethings. Here's where we have the external IP addresses coming in, and these are being routed to the Nginx load balancer as part of that. I found it easier to deal with Nginx and place certificates in it than dealing with like a JBoss or a WebSphere or any of that. It's really straightforward. It makes it easy, and you can do things like reverse proxies to route to different containers. That's how we do the front end, back end, is through the Nginx. But that's going to be a type load balancer as part of that. And we're routing both regular HTTP and HTTPS traffic to that Nginx. Let me see. Now you can see I have another demo out here that uses Istio as the inbound service mesh as the inbound gateway. And this is going to take in a bunch of different ports and do some extra things with the transactions coming in. But like I said, when you create your cluster, you're going to create your pods and your replica sets, and make sure you create your services. And if you're doing any volume mounts, you'll want to do your mounting at that level. I have no applications, and I don't think I have anything under configuration. This is all just service account stuff. So basically, when you go through, just create cluster, and it's going to say, how big you want it. Just start with the basics. From there, it'll go ahead and tell you how to connect up from the command line, what commands you need to run. And then from there, you just have to take your YAML file that defines your pods, your services, and that's basically about it. Your ingress, your load balancer, and you're ready to go. I would start with just first containerize your application, and then get it to run with a Docker run. So if you just have a simple application that you want to start with, or piece of a bigger application that you want to pull out, take this one function, like I said, that's pretty low level, pull that out, put that in, make that run on its own in its own container. And then once you get that going, go ahead and take that and roll it into a Kubernetes cluster with a replica set of 1. And then you're good to go on that level. You can run Kubernetes in Minikube. It can run on bare metal. It can run in VMs. You can run it in any of the cloud providers as well. I prefer Google because they invented Kubernetes. It came out of a product they call Borg that runs all of Google. So AWS was and they're very big, and Google's very big in the, and Microsoft are very big in the contributing to Kubernetes. AWS hasn't been a very good player in the open source world. Last time I checked, there was 20,000 developers on Kubernetes worldwide. So it's moving. Any questions from anybody on the, if you want me to dive into anything in more detail?
Sure, I have a question.
Yeah.
Since I'm just getting to know Docker and now Kubernetes, how do they play together?
Okay. So let's see. I have one. Oh, I don't know if I have one here. So
Or like how are they intrinsically connected?
Yeah. Yeah, it's through the a YAML file that defines that. I don't think I have, it's on another server I don't have access to because the Wi-Fi network here. Well, let me see if I have one. Yeah. So there's one. Actually, go back to this one. I lied. So look at cart service. Okay, so this is going to, this is the Docker file to build the cart service. And it looks like it's based on Alpine, which is one of the base operating systems. Basically, this command here says change the working directory, copy everything from my current working directory that I'm building from into the app directory, run some .NET pieces, because I believe this is like a .NET C# application running on Linux. It's just one of those. Then we go through and grab some, this is basically going and pulling down some packages and bring them in so we can execute them. And then we add additional libraries to the base install. And then from there, we're going to copy some additional files from the cart directory into our app directory. And then every single Docker file has an entry point, or can have an entry point. And this one's just saying start up the cart service to run in the foreground mode. You want your Docker containers to run in foreground. That way they never exit. So like if you have like a an app server like a Tomcat or IIS. You know, a Tomcat, you want to start that process and just let it run in the foreground, and the Docker container will run as a daemon then underneath the Docker daemon. So that's going to be creating our container, and this is the input to the Docker build. Now from there, let me see. Try to remember which one I have. I don't remember if I have it in this one. Let me try down another one. I know I have another repo here, example. Jenkins. Sorry guys, I'm trying to find this one file to show you guys. Let me go to this route. What I'm trying to find is a Helm chart. So the Helm chart is a way to template your YAML files for your deployments to the Kubernetes cluster. I'm just trying to find a good one. I've had one.
It's in the category of what's now called image build. So Helm, Ansible operators, something else. Well, there's Ansible Galaxy roles you could use too for doing that. But it replaces what you might have written in a build script. And it defines the what the image of your container is going to look like.
It's kind of like an Ansible playbook.
Exactly.
It's exactly like
Yeah.
that.
That's the exact way to think of it.
So if in your Kubernetes pipeline, if you think about the landscape as a whole, there's a category that is defined as container registry and image build. So you build your image and then you register it.
There's one.
The same way as you would have compiled an executable and stored it in the binary repository.
So look at the template. So this one's going to be a little weird because this is for Istio. But that's part of the Helm chart is just defining some variables to it. I'm trying to find one that's a better example.
Just look online, yeah.
Okay. Let me just zoom in. Sorry, guys. Let me just get this so you can read it. So this is just giving you some basic information about, you know, what you're going to pull, where it's going to come from. Those type of keywords are going to be placed into the Helm chart itself. And then we have the template, which is going to give us the actual, like in this case, if you look at the flower, this is the YAML file template that Kubernetes is going to be looking for. So this is a kind deployment. This is going to be our chart that we use. And then eventually get down into, should be down here where we talk about the image that we're going to grab. Here's our replica set that we're defining, our rolling update strategy. And then here we're going to pull our image secrets. Those are all part of that. And then our containers, which containers are going to belong to that pod. This one's a pretty complicated one. I just picked by random. And then let me know. I can get you, when you're at that point, let me know. I'll get you a simpler one to work from to get you started.
Sometimes it's mistaken as a deployment tool, Tom. But
Yeah.
It's a deployment from the sense that you're building an image and deploying it into a container.
And then you have your service. Basically, this is your service account and the information for the service account. They try to keep these things pretty simple at the high level. But like I said, if you try to reverse engineer this, it's just not readable. I could find, I have that other one somewhere. But Helm is the way you're going to work, the best way to work.
So we have like 15 minutes. Is there any particular questions that we might be able to field for you before we take off?
Good.
Good.
Thank you very much.
Yep.
Very informative.
No
Good.
problem.
Good.
Thank you.
And then we'll be doing one in Albuquerque. And is James still on the line?
I don't know.
Did you ask?
No, he's not.
Okay. I will be sending out the announcements. We have a guest speaker coming for Albuquerque. I think he's from Twislock. He's going to talk about security, container security in particular. Now, if we do that at Big Bite, which is downtown, and it'll probably be around the middle of January. And please come December 5th to Cart Labs, 5:30 to 7:30. Sounds great. Thank you.
Any other questions from you guys out there in Zoom land?
Well, I was wondering actually, you mentioned earlier that when there are a lot of unmanaged, not well versioned microservices lurking in graveyards and such. I was wondering, can you measure that in terms of a cost, or what sorts of problems actually do you see with that?
What ends up, the word spots like where an issue's been fixed, but that particular application is still using an old version, so they open another issue for the same thing that's already been fixed. You get into scenarios that will, yeah. So that's going to be one of those costs of when you have too much stuff out there running. You know, you really want to limit the number of versions that you want to run in production at the same time. You know, when you get into, you know, past like 6 versions of a service at the same time, it's going to get confusing. And what you want to do is you want to make sure you have a good deprecation strategy in place on how you can collaborate with the developers, that this team is going to roll out a new version, and 2 versions from now we're going to delete, you know, version 5. So you guys have to start moving off of the deprecated version. Now, one of the things that you'll run into that we focus on with DeployHub is keeping track of who's using what. So to make that communication easier, we can say, for this component, this version that's five releases old, who's using it, and we can run a report that tells you these are the people that we need to go talk to tell them they better move up to a later version. You know, if you look at, I don't know, do you guys use Jenkins at all?
Yes, we have.
Yeah, so you have experience. So Jenkins runs this problem itself with all of its plugins.
Yeah.
They had problems where one plugin was dependent upon another plugin, and you try to move forward, but you break something else. That scenario, and that's what.
We had a problem like that with our webhooks to GitHub one time.
Oh yeah.
And it may have been involved with our institutional firewall also. We updated Jenkins, and suddenly Jenkins got incredibly picky about the security on our webhooks. And so
Yeah.
the plugin didn't work. It's very interesting.
And it was a minor update too, so
It's very
we
minor,
were confused because why did the API
Yeah.
change if it's a minor update?
Yes, so there you go. There's an example.
Yeah.
There's an example of what you've experienced with dependencies and how they can affect each other. Now, Jenkins is just, a web server running plugins, but those plugins are dependent upon each other. The same thing, that same concept is going to apply to microservices when you transition to that world.
Yes.
Good, great. Good answer. Thank you.
Yeah, I have a question.
Oh,
So
one-
I've heard about this strategy where if you use semantic versioning, then whenever you have a patch or a minor upgrade, you can automate the process. But when you know for sure that you're going to release a major update to the service, then you should definitely communicate with ops and not automate it at all, because that's going to regress something in the process.
So what I've been doing is taking the viewpoint of, so semantic versioning is version 1.5.1. That's that idea. Now, the problem with semantic versioning with Docker containers is if you tag the container with a semantic version, you can go and retag it to another container down the road. So it's mutable and not immutable. So that's one of the problems with semantic version tagging. Now, one of the things you can do is, what I like to do is use semantic versioning in conjunction with the git commit SHA, the short version of that, and use that, the pair of those together as the image tag name. So when I apply that to the Kubernetes cluster, I know that I'm going to get a new version put out there into the cluster because it's a more unique name than just somebody with the semantic version. The other thing I like to do is there's a label command in your Docker build that you can pass in and basically comment things. And in that comment for the container, I put the semantic version as well as the git commit as comments in the container. So if I ever need to go backwards, I can do a Docker inspect and pull that label out and figure out what the true git commit was and the true semantic version was of the container. Because the tags can move, you can't trust the tags.
Mhm. Oh,
Interesting. Well, thank you.
Thank you. Thank you.
Yeah. Now, if you really want to be really locked down and not get surprised by anything, in your Docker build, you want to, at the very beginning, it has from image. So up here it has from image as builder. What you could do is you could say from Alpine, and then you could put it :SHA and the SHA number of the Alpine build that you want to consume. That way, if somebody, Alpine gets rebuilt every day, that you want to peg your build to a certain version of Alpine that you've tested with, you can do that by adding the SHA on there as part of that. And things like also on these levels, when you do your package installs, you want to put the versions of the packages that you want to install as well. But that's getting to where you can really create you're not going to get surprised if you do a Docker build 5 minutes from now and you get a different change that's occurred.
Yeah.
I've run into that before where all of a sudden, for some reason, I was doing like a wget and the thing wasn't there anymore. It's like, where did it go? It's like,
Major update. Breaks everything.
and a lot of it's just minor stuff, just minor maintenance that people are applying, security patches to the base operating systems at the image level, and then you're grabbing those. And I remember it was Python. They ended up changing Python 3. They ended up removing one of the default packages and they made it optional. So I was counting on it to be there as part of the default Python install. and they changed it to be an option one that I had to do an extra command to bring into my image. But 2 days ago, it worked fine.
Yeah, it's good to have that extra control over your image. Yeah.
And the other thing, if you're really worried about your images, you know, instead of pulling from like Alpine or, you know, like a Java image, you know, like you get like Java 1.8 as an image, you can build them from scratch. You can do a distroless. So basically it's an empty Docker container that you have to go and put every single dependency in there. Now, it takes longer to do that, but you get two benefits. One is you know exactly which dependencies are there, and also your image is going to be smaller.
Yeah, I think we can do that.
Because every time you run a do like a copy or a run, that's creating a new layer in your container in your image. So this is going to create a layer which is basically a fancy zip file, and then we're going to create another layer and another layer, and finally we're going to have another layer. Now theoretically, Docker build is supposed to reuse a build cache. So if something hasn't changed, it should skip over it. But anything like the apt-gets, any of those APKs, yum, they get run no matter what. So that's one of those catches as well that you'll run into. You'll see that. And that just takes you, every time you do a layer, it causes it to be longer to download from the Docker repository.
Oh, thank you for these tips. Our previous work with Jenkins, we didn't actually use Docker, but our next work certainly will.
Who are you using for your source code? Are you using like GitHub or GitLab?
We use both GitHub and GitLab.
Okay. And then do you have a cloud provider?
Yeah, Azure.
Okay.
We have a special license with them. Yeah.
Okay. Yeah, so Azure is going to have, you know, all the cloud providers have some sort of desktop, dashboard view into their world. And if you need to run your clusters on-prem, then I'd be looking at something like Rancher to run that. It'll manage the cluster, the VMs and the cluster for you a little bit easier. It gives you a dashboard world instead of trying to do it yourself.
Interesting.
Any other questions?
I guess we're good here.
All right. Well, thank you guys for joining in. And
Thank you. Thank you so much.
Yeah.
yep, if you're in the Santa Fe area on, what was the night? December 5th, Tracy?
December 5th at Descartes Labs,
Yep, December 5th, Descartes Labs,
downtown Santa Fe,
downtown Santa Fe, what, 5:30?
5:30 to 7.
5:30 to 7:30.
No talk, just beer, wine, and
Just
network.
just socializing,
Yes.
no work.
Oh, nice.
Great. We'll pass the word along.
Yeah.
Great, thank you guys.
5:30, you said?
Yep.
5:30.
All right, take care, everybody.
Well, take care and thank you.
Thank you.
Descartes Labs
You're
is
welcome.
Pretty cool. It's fun.